So we have arithmetic formulas and geometric formulas. The sum ones are going to be given to you guys, but you have to know which one goes with which. So we'll give you the sum formulas. The general formulas you guys have to memorize, but we'll give you the sum ones and you have to know which one goes with which type. Yes, you'll get a calculator. So arithmetic is adding or subtracting to get from one number to the next. Geometric is multiplying or dividing. So let's take a look at the second one on this page. So it says write the first 5 terms of the sequence. Assume n begins with 1. So to write the terms, what would I need to do? Let's find a sub 1. Plug in 1. So we have 3 times 1 over 1 squared minus 2. Even though you can plug this in your calculator, I need to see your work. Also, all the questions are going to say exact answers, no decimals, so you make sure you know how to add fractions and stuff like that. So 3 over 1 minus 2 would be 3 over negative 1, which is negative 3. To find our second term, we plug in 2. So 3 times 2 over 2 squared minus 2. So 6 over 4 minus 2 would be 6 over 2, which is 3. Find our third term, we plug in 3. So 3 times 3 over 3 squared minus 2. This would be 9 over 9 minus 2 would be 9 over 7. And then a sub 4, we plug in 4. 3 times 4 over 4 squared minus 2 would be 12 over 16 minus 2. 12 over 14, which would simplify to 6 over 7. I'm just going to find the first 4 terms because that's all I have space for. But just make sure you read the instructions. They might say find the first 5, find the first 10 terms, or just find the first 3. Just read the instructions. I'm going to go down the page a little bit. So I highlighted which ones I think are important to know, so I might skip some of the ones on the review, but it's homework, so just whatever we don't have time to do in class, you got to do the rest of them for homework. So it's asking us to find a sub 19. How would I find that? Plug in 19 into all of our ends. So I have negative 1 to the power of 19 minus 1 times 19 times 19 plus 1. Be super careful with your order of operations here. What would I do first? The brackets. Perfect. I'm going to do the exponent up top here because that's not going to change anything. So 19 minus 1 would just be 18. I have 19 times 20. What would I do next? 19 times 20. So that would be 380. And then negative 1 to the 18th power would be 1. Be super, super careful when putting negative numbers raised to an exponent in your calculator. You have to put the negative 1 in parentheses. Because if you don't put parentheses, it's going to think that negative is not being raised to the 18th power. So make sure you're careful with your negatives and parentheses in the calculator. So 1 times 380 would be 380. All right, let's look at the next one. So you have to write the expression for the apparent nth term of the sequence. So first we want to figure out if it's geometric or arithmetic. Am I adding to get from one number to the next here? If so, what am I adding? Negative 5. Negative 5, negative 5. Perfect. So our formula, would this be arithmetic or geometric? Arithmetic. So our arithmetic formula is a sub n is equal to a sub 1 plus n minus 1 times d. So a sub n is equal to, what's a sub 1? Negative 3. Awesome. That is our first term that's given there. Negative 3 plus n minus 1. We're just coming up with the general nth formula for it, so we don't have anything that we're plugging into n. And what is our d? Negative 5. That's our common difference, which is negative 5. Now we have to simplify this. How would I simplify? Distribute the negative 5. So we get negative 3 minus 5n plus 5. And then lastly, just combine our like terms. So this would be a sub n is equal to negative 5n plus 2. All right, looking at the next one right below it. What am I adding or multiplying to get from one term to the next? It might help. Let's change 1 to be a fraction. So that would be 2 over 2. Three over 2? Let's check. So I'm adding 3 over 2 to get 2 over 2. I'm adding 3 over 2 to get 5 over 2. What's 5 over 2 plus 3 over 2? That would be 8 over 2. So is this an arithmetic sequence? No. So you could say it's not an arithmetic sequence, but let's do it just in case it was an 8 over 2. So I'm going to change it to be 8 over 2. Now is it an arithmetic sequence? Yes. So we're going to use our arithmetic formula. We have a sub n is equal to a sub 1. What's our first term? Negative 1/2 plus n minus 1 times d. What's d? 3 over 2. How would I simplify? Distribute the 3 over 2. Bless you. So a over n is equal to negative 1 plus 3 over 2n minus 3 over 2. What would I do next? Combine like terms. So it's negative 1 over 2 minus 3 over 2. It would be negative 4 over 2, which is negative 2. So a sub n is equal to 3 over 2n minus 2. So let's look at the one right below. So here I want to simplify. Yes, you can just put it in your calculator, but I need to see what you are putting in your calculator. So I need to see your work. We have 12 times 11 times 10 times 9 times 8 times 7 factorial. I'm going to stop there because I see that I have a 7 factorial on the bottom. Then we also have 5 factorial on top. So this would be 5 times 4 factorial. I'm going to stop there because I see that I have a 4 factorial on the bottom too. So the bottom, I have 4 factorial and 7 factorial. If you have the same thing on the top and the bottom, you can cancel it out. That's why I stopped there. You could keep writing it all out. So you'd have 7 times 6 times 5 times 4 times 3 times 2 times 1, which would cancel out with the 7, 6, 5, 4, 3, 2, 1 on the bottom. So 7 factorial on top cancels out with the 7 factorial on the bottom. The 4 factorial on top cancels out with the 4 factorial on the bottom. So now we're just multiplying 6 numbers together. So in the calculator, I'm going to put 12 times 11 times 10 times 9 times 8 times 5. So you should get 475,200. Again, you could just put it all in your calculator, but I need to see your work.
12, 11, 10, 9, 8.
And 5. Any questions here? All right, looking at the one right below it, I'm going to change the values, the starting and the ending one. Let's say we start with I is equal to 6 and end with 112. So we're finding the sum. Is this an arithmetic sequence or a geometric one? How did we know that it's arithmetic? Because it's 8 times I minus 5. It's written in y equals mx plus b form, kind of like that. So we know if it's written like this, that it would be arithmetic. If it was written like, let's say, something that has an exponent. So if it was like 5 to the power of I or something like this, then this would be geometric. So if it has an exponent, it's going to be a geometric sequence. But here, it's kind of written in slope-intercept form, so it would be arithmetic. So our arithmetic sum formula is S sub n is equal to n over 2 times a sub 1 plus a sub n. So first thing I want to find is my n. N is the number of terms we have here. How would I find the number of terms that we have? Stephanie, how would we find the number of terms? So it's the last minus the first plus 1. Because if we had something that was from 1 to 5, you could count 1, 2, 3, 4, 5. We have 5. So it's not just last minus first, because that would only be 4. But it's last minus first plus 1. So this would be 112 minus 6 plus 1. So that would be 107. So n is 107. We have 107 terms here. If you want to count, you can count from 6 to 112. The numbers will be like this on the quiz, so it'll take you a while to count. You probably won't have time for that. Next, let's find a sub 1, which is our first term. What am I plugging in to find the first term? 6, because 6 is the number that I start with. So we're technically just finding a sub 6 here. So this would be 8 times 6 minus 5. So 48 minus 5 would be 43. And then a sub n, what would I do to find a sub n? Plug in, we plug in 112, because that's the last number. So 8 times 112 minus 5. So this would be 891. So now we're going to plug all of these into our formula. So S sub n is equal to 107 over 2 times 43 plus 891. So in the calculator, the sum of our terms are going to be 49,969. So like the 107, you only used to plug into n. But then for your first and your last, you're using the first number that it gives you and the last number that it gives you to plug it in to find those. Would the one right below it, would this be arithmetic or geometric? Arithmetic. Geometric would be if it had an exponent. So just make sure you're able to identify the two. So let's look at, it's kind of in the middle of the page. It says, write the formula for the general term, the nth term of the arithmetic sequence. Then use the formula for a sub n to find a sub 20, the 20th term of the sequence. So first thing we want to do is find the formula. It tells us that it's an arithmetic sequence, so we just have to figure out what we're adding or subtracting to get from one number to the next. What would that be? -9. Awesome. We're subtracting 9. You can always do the second term minus the first. So if we did 1 minus 10, that would give us -9. So that is our D, our common difference. Our general formula for an arithmetic sequence is a sub n is equal to a sub 1 plus n minus 1 times d. What would a sub 1 be? 10. It's the first term. It's going to be given there. 10 plus n minus 1 times d. What's d? Negative 9. So let's simplify this to find our general formula before we find the 20th term. So what would I need to do to simplify? Distribute the negative 9. So a sub n is equal to 10. This would be minus 9n plus 9. So a sub n is equal to negative 9n plus 19. So that would be our general formula. What else is this question asking me for? The 20th term. So how do I find the 20th term? Plug in 20 into the n. So a sub 20 is equal to negative 9 times 20 plus 19. So we plug this in the calculator. Negative 9 times 20 would be negative 180 plus 19. We get a sub 20 is negative 161. So on the next page, it says write the formula for the general nth term of the geometric sequence. So our geometric formula would be a sub n is equal to a sub 1 times r to the power of n minus 1. So to find our common ratio here, we could do the second divided by the first. So that would be 12 divided by 6, which is 2. So let's check. If we multiply 2 each time, do we get the next one? Yep. So what's our common ratio? 2. What is a sub 1? 6. That's our first term. So that would be given to us, that's 6. So 6 times r, which is 2, to the power of n minus 1. This is just asking for the general term, so it would just be this. Yes, the exponent is just on the 2, so be careful. If this was asking us like to find the 20th term or something like that here, and you would have to plug in a number, it's just the 2 that has the exponent. So you have to follow your order of operations PEMDAS. Parentheses, exponent. You have to do the exponent before you multiply. So you have to do the exponent before you multiply if you were multiplying this out to find a number. All right, let's look at the one right below, not right below, but a little bit below. It says find the indicated sum. Use the formula for the sum of the first n terms of the geometric sequence. So is this finite or infinite? Finite, because it has a starting and an ending. If it was infinite, it would have the little infinity symbol or the dot, dot, dot. So this is finite, so we use our finite sum formula. So S sub n is equal to a sub 1 times 1 minus r to the power of n over 1 minus r. So I need to figure out what a sub 1 is, what my ratio is, and how many terms we have. How would I find a sub 1? Plug 1 in. 1 is the first number that it gives us, so whatever the starting point is, that's the number we plug in to the variable there. So this would be 2 times 4 to the power of 1. 2 times 4 would be 8. So a sub 1 is 8. What is our ratio? 4. It is just the number that has the exponent. So it's whatever the number that has the exponent is. So our ratio is 4. And what is our number of terms? How many terms do we have here? How many? 5. Awesome. You can count. We're plugging in 1, 2, 3, 4, 5. Or you could do last minus first plus 1. So it'd be 5 minus 1 plus 1, which is just 5. So the last minus first plus 1 is really just helpful if you had like a whole bunch of terms and you couldn't just count from the start to finish. So let's plug it into our formula. So the sum of our 5 terms is equal to a sub 1 is 8 times 1 minus 5 to the power of 4 over 1 minus 5. No, 1 minus, sorry, it's the other way around. R is 4. So 1 minus 4 to the power of 5. Over 1 minus 4. So make sure you follow your order of operations. I'm going to start with the top and do the exponent first. So I have 4 to the 5th power, which would be 1024. And then 1 minus that would be negative 1023 times 8. We get negative 8,184 over, I did 1 minus 4, which is negative 3 on the bottom. Hopefully this divides. If not, we just leave it as a fraction. It does divide. So we get positive 2,728. So if it didn't divide evenly, just make sure you simplify your fraction and you can leave it as a fraction. Let's look at the one right below it. We have to find the sum of the infinite geometric series if it exists. How did we know without the directions telling us that it's infinite? How would we know that this one was an infinite series? The dot, dot, dot. And then it's asking us for the sum because it has plus for in between all of our terms, so we're adding. So our sum for infinite geometric series formula is S sub n is equal to a sub 1 over 1 minus r. So what is a sub 1? 48, that's our first term, which is 48. How would I find r? We're dividing by 4 to get from one to the next. We would just do the second term over the first term, which simplifies to 1/4. So we're multiplying 1/4. So r would be 1/4. So yes, we're dividing by 4, but our formula is for what we're multiplying, so that would be 1/4. So let's plug it in. S sub n is equal to 48 over 1 minus 1/4. Now the directions on the quiz are going to say exact. So let's work it out with our fractions here. Let's just not plug it into the calculator right away, just in case it ends up being a decimal. How do I subtract fractions here? I'm going to turn 1 into what? 4 over 4. Because it's still 1, we're just changing the way that it looks. So we have 48 over, we subtract the numerator, so this would be 3 over 4. What do I do when I have a fraction in a fraction? Keep, change, flip. So keep the top, change to multiplication, and flip the bottom. So then here we can do 48 times 4 divided by 3, which is 64. So here we have to find a sub 1 and a sub n, so the formula, given a sub 3 and a sub 8. So it doesn't tell us here, but this is a geometric sequence. It will tell you if it only gives you 2 terms, it'll say if it's geometric or arithmetic. So we're going to use our geometric formula. So that is a sub n is equal to a sub 1 times r to the power of n minus 1. But here, I don't have a sub n and I don't have a sub 1, so what would I have to use instead? Perfect. Why did we plug in a sub 8 first? Because it's farther from our first term. So you always start with the one that's farther. So a sub 8 is equal to a sub 3 times r to what power? 8 minus 3. So just like before, it was n minus 1. We use 8 minus 3 now. And then let's plug in what we have. A sub 8 is 1 over 625. A sub 3 is 5 times r to the power of 8 minus 3, which is 5. All right, and now we are trying to solve for r. So what would I do to solve for r? Divide by 5. I'm going to change this to be 5 over 1 and keep change flip since I have a fraction and a fraction. So keep the top, change to multiplication, and flip the bottom. So this would be 1 over 5 times 625. So 3,125 is equal to r to the 5th power. What would I do next? Take the 5th root of both sides. So what do you think the 5th root of 1 over 3,125 is? 1 over 5. So our r is 1 over 5. What would I have to do next? So we have a sub n is equal to a sub 1.
Pardon the interruption. This varsity baseball is time, please.
All right, so I still don't know what a sub n or a sub 1 is. What could I do next? I could just use a sub 3 instead of using a sub n, because I know what a sub 3 is. So I'm plugging in 3 into the ends. A sub 3 is 5, so 5 is equal to a sub 1 times 1 over 5 to the power of 3 minus 1, which is 2. Yes. So 1 over 5 squared would be 1 over 25. What would I do next? Multiply by 25. So it cancels out with the 1 over 25, and then I have 25 times 5 would be 125. So our first term is 125. So that was part of our question, but it also asked for the general formula. So I'm going to write a sub n is equal to, what's our first term? 125 times r, which is 1 over 5 to the power of n minus 1. So the first thing we had to do was find our r, then find a sub 1, then plug that into our formula. So you just have to use what you're given, and you can substitute that into your formula. So here, when we found a sub 1, we were still using our general formula. A sub n is equal to a sub 1 times 1 over 5 to the power of n minus 1. But we didn't know what a sub n is or a sub 1. So next, to find a sub 1, we could use either one of these that we were given. So we just decided to use a sub 3. So we plugged 3 into the n spot. All right, I'm going to do one more like that, but this one is going to be arithmetic. I made this up because there's not one on the review, but you'll probably see one on the quiz. So I'll probably write this down. So it'll tell you that it's arithmetic. And it's asking us for the 97th term. So let's start with what we have. Our general formula for an arithmetic sequence is a sub n is equal to a sub 1 plus n minus 1 times d. So I don't know what a sub n is, a sub 1 or d. What could I do here? Plug in a sub 12. Why a sub 12 first? Because it's farther away. We start with the one that's farther from the first term. So a sub 12 is equal to a sub 4 plus what? 12 minus 4. So instead of using n minus 1, we're using 12 minus 4 here. Times d. So I know what a sub 12 is. That's negative 41. And a sub 4 is negative 9. Plus 8 times d. We can add 9 to the other side. It's negative 41 plus 9. Negative 32. Divide by 8. So what does d equal? Negative 4. So now that we found d, what can we do next? Plug it back in. So we have a sub n is equal to a sub 1 plus n minus 1 times negative 4. Now we still don't know what a sub n or a sub 1 is, but what could I do? I can plug in either a sub 4 or a sub 12 into the a sub n spot. So I could say a sub 4 is equal to a sub 1 plus, what would go into the parentheses now? 4 minus 1, awesome, times negative 4. And a sub n, we know, is negative 9. Or a sub 4 it was. So I replaced a sub 4 with negative 9. Now we're just solving for a sub 1. So negative 9 is equal to a sub 1 plus 3 times negative 4. So a sub 1 minus 12. So we add 12 to both sides. So 3 is equal to a sub 1. Now that I have a sub 1 and d, what could I do? I'm going to plug it in to find my general form. So a sub n is equal to a sub 1 we now know is 3 plus n minus 1 times negative 4. And I would just plug in 97 into n. So a sub 97 is equal to 3 plus 97 minus 1 times negative 4. And then just solve, and that would be your 97th term.